Welcome to homework.
In this problem, we have to explain what the correspondence principle says about the relationship between quantum mechanics and classical mechanics. So remember that the correspondence principle was formulated by Bohr, and basically what it says is that when we have a quantum theory that is designed to explain very well very small systems and systems with small energies, usually, if this is actually a good theory, if this is indeed a theory that explains the world more fundamentally than classical theory, then in the limit, when we take the energy to be great, so the energy, we have big energies, and more generally, not only big energies, but big quantum numbers, and also situations where classical mechanics has already been proven to work, like our everyday lives, then quantum theory should correspond to, so corresponds to classical theory. And this makes sense because if we're saying that quantum theory is more fundamental, okay, fundamental, then it must explain everything classical theory does plus something else. We know that for very small energies and very small systems, classical theory does not apply, while quantum theory does. So we explain quantum theory to also, we expect, quantum theory to also explain the world in the classical limit. It may not be very useful or practical, actually, to apply quantum theory in our everyday lives, but at least in principle, the quantum theory should be applicable to everything classical theory explains. Okay, so um, just summing it up here, quantum theory must be must explain well what classical theory already does.